The next problem is going to be problem 8.154, and here I drew a little sketch of our little problem that we have here. Now the first step here is to write Bernoulli's equation, again considering our major losses and our minor losses in the piping system. Now we can simplify our expression, knowing at point 1 and at point 2 we will be at atmosphere. That means that they cancel out with each other. Also, we'll assume that our tank is large enough that the velocity at v1 is going to be 0. Additionally, we also have that our variation at our height at point 2 is going to be 0. We can rewrite this expression as being gz1 minus v2 squared over 2 is equal to FL over D V squared over 2, which is the loss over the length of the pipe, plus K V squared 2, which is the loss either by the entrance to the pipe. Here we can write an expression then for V as a function of F and K. Now, because in the problem it says that we are working with cast iron, we know that the roughness is going to be 0.00085. This means that we can find our relative roughness by dividing by the diameter, which is 1 inch or 1/12 of a foot. Now for the first part of the problem, we're going to assume a reentrant, so our minor loss coefficient will be 0.78. As we now know K, we can even further simplify our expression for the velocity. Now, because f is a function of the Reynolds number and the Reynolds number is a function of our velocity profile, we have to make an assumption of our initial Reynolds number and then proceed to check to see if our initial assumption was correct. Here, my first assumption, I will assume that the Reynolds number is 10 to the 6. Using a relative roughness of 0.0102 and our Reynolds number, we can find that our friction coefficient will be about 0.038. Replacing the friction factor in our equation for the velocity, we get a velocity of 8.47 feet per second. Now our next step here is just to verify that our assumption for the Reynolds number was correct. So we're placing in, we get 2 to the times 10 to the 6 for our Reynolds number, which is very close considering that if we were to change the Reynolds number on the graph, we would still get the same friction factor. And finally, we obtain that our final flow rate is going to be 0.046 cubic feet per second.